Hash set is based on a hash table, because there's the word hash there. And tree set is based on the black tree, because there's the word tree there. Okay, so now all together, those things are related to the grand interface called collection. Okay, it's that collection. So so now you have a collection super interface. Now I don't know if you paid attention. Whenever you look at the Java doc, sometimes you look at the documentation. It says the parameter or the argument could be a collection. Okay, if you paid attention, you will see that a collection. And so, what is a collection? A good example would be, say, you want to do array list. You know, array list. We 148. We use array list so much, right? Array list is a array list. That's how you use it, right? Array list, and you put some kind of data type in there, right? And say list, and it equals new array list. Okay. Now, what you can put inside here as an argument is actually a collection. Think about it. So in other words, if you have a collection of data, and you use that as an argument for that array list constructor, and that collection of data, can be used to turn into an array list. Okay. So what does that mean then? What does that mean when the Java doc says collection here, collection type, right? So what that means is any kind of data structure that ultimately implements the collection on top are allowed to be put into that array list constructor to build the array list. So who are they? All the lists and all the queues, all the sets. You see that? Because they all ultimately implement collection. So you can put a set in there. You can put a set in there, like a tree set or a hash set. You can put in there, or you can put a list. You can put a queue. You can put in here, and array list can take the data, read the data, whatever as long as it is a collection data type. Okay, it could be list, queue, and set, including stack, including another array list, including linked list, including priority queue, including hash set and tree set. All the things you can put in there, and the array list will take the data from those data structures and build an array list for you. Okay, so why is that possible? Because that's called polymorphism, right? Because all those concrete data structures, array list, stack, and linked list, and priority queue, hash set, tree set, they all belong to the collection type because they all ultimately implement collection. That's what it is. That's what it is. Okay. So you see a lot of this. Whenever you see a data structure, Java doc, you often see that collection. Even you may have, generic. Okay, collection of any type, even it's okay. You may even sometimes see E extends another type. You can see that as well. So that tells you the benefit of using such a top interface, collection interface that allows you to unite many data structures into the same category. So because of the existence of the collection interface, many different things belong to the same data type. And all the things on the third row, they all belong to collection type. Okay, so that's the benefit of using a interface. Now, I also want you to pay special attention to the class linked list. If you take a look at the linked list, you also see that it implements two interfaces. Okay, on the left, you see linked list has a dashed line pointing to list, right? And then linked list also has to the right, line pointing to the Q interface. You see that? So that tells you that linked list is a list type and also a queue type. And then of course, it's also a collection type. So a linked list belongs to all those types. It belongs to its own type, like a linked list type. It could be also list type, it could also be queue type, could also be a collection type. So whenever you see a API that will take a list, linked list can go in. It will take a queue, linked list can go in, take a collection, linked list can also go in. And then it implements all three interfaces. Okay. Now it also shows the benefit of using interface on a different aspect of it. If you know a Java class, in this case linked list, can have more than one interface, right? In this case you have two, right? But you can have as many as you like, okay? But that's not the case for superclass, because each concrete class can only have up to one superclass, right? You can only have one superclass. So by using interface, we can have more than one. In this case, we have two, the list and the queue, right? So that's really, really nice. So that's the general idea, general picture of anything we call collection. Now, from this point on, if someone mentioned to you collection, the word collection, it means any of the three things. It means any kind of list, means any kind of queue, means any kind of set. That means could be array list, any kind of stack, linked list, priority queue, hash set, queue set, and all the other things, you know, like a linked hash set, for example, we talked about. That's also part of the collection. Okay. The only thing that's not a collection is the second diagram on the same page, which is a map. You see, map is not even related to collection. You see, there's no lines connecting map to collection. You see that? So map is its own interface. It has its own interface, and the map has, and then what is a map? Keeps association between key and value objects. Both have to be objects, no primitive. Okay, so you have a hash map, and you see the dashed line with that little arrowhead that was closed but empty, and also tree map has dashed line pointing to the tree, pointing to the map, has a like an empty but closed triangle arrowhead. That means implements. Okay, so that means hash map implements map, tree map implements map. So these are called map, hash map and tree map, then nothing to do with the collection. Okay, so don't, if a data structure or constructor will take like a array list, you take a collection, you won't take a map, because map is not collection. Right, from the diagram you can see map has nothing to do with the collection, but everything else is okay. We know queue is okay, list is okay, set is okay, because they all belong to the general collection type, but not a map, not tree map, not hash map. Any map, no collection. Okay, so this is the general division between collection and map. Now, I want you to pay special attention when you see collection. Okay, because this interface is on this capital C, it's like a class, right? Collection. But I want you to especially remember this is entirely different from a Java API class. You probably know which one I'm talking about. It's called collections with the S in the end. That is entirely different thing. That's not even an interface, that's a class. Okay, it's a class collections with the S. That has methods like sort, shuffle, it has a lot of other methods, but not interface. So whenever you see collection and collections, those are entirely two different things. Don't mix them. Okay? Collection singular is interface. It's a super interface that covers everything, all the structures we learn except map. Okay? And a map is a category of its own, and it's not related to collection. you have some data structure, will take a map, then that will take either hash map, both hash map and tree map. Okay. And whenever you say map, you understand you need to keep both keys and the value. Object, again, make sure object, not primitive. Okay. All right. So that's the first page. Hopefully that will give you a pretty good idea how data structures are divided into two camps. Okay, two camps, collection camp and map camp. Okay, and how the relating together. Right. Now, the second page I want you to look at it is some detailed elaborations as to these two camps. Right. The very first one, I think on the top of the page, you see the three words, Java Collections Framework, right? Now, Java Collections Framework, meaning that's Java's data structure API, is a framework for all Java API, data structure APIs, included. So even though you see the word collections, that doesn't mean it's the collection interface only, so it has a map included as well. Okay, so Java collection framework included the map and the collection interface subclasses. You understand? That means everything in Java, as long as it has to do with data structures, and that it goes into Java collections framework. And the only thing that's not included in this, I think, is arrays. Okay, arrays is just separate the animal of its own, so it's not even included into the Java collection framework. Okay, so the Java collections framework, that's a definition, you see. It's designed to support numerous collections in a hierarchical fashion. Hierarchical fashion means implements, extends, subclasses, that kind of thing. It is essentially made up of interfaces, implementations, and algorithms. So it includes interfaces, which we talked about, right? List, queue, and a set, and also collection and a map, right? Implementations means the concrete classes, because they actually implement those classes, right? And then also, obviously, the algorithms. Now, algorithms are the things like a sort and those things, maximum, max, and min, get the maximum value, minimum, shuffle, so on and so forth. So we'll see a lot of those in a moment. Okay, so that's the definition. If you look at definition, you see array is not inside that picture. Array is not implementing any particular interface. It's not implementing those there's a hierarchy in the hierarchical fashion. So array just animal its own. Now let's take a look at the collections interface. The collection interface. Collection are objects that group multiple elements and store, retrieve, and then manipulate those elements. The interface collection is at the root of the collection hierarchy, okay, at the very top collection. So we're not talking map, don't forget that, right? We are talking about the collection interface on the first diagram I showed you, the first page. So we're not talking map. So the interface collection is at the root of the collection hierarchy. Sub-interfaces of the collection include the list, queue, and the set. That's the second row. Table 1 is the right below it. Show these interfaces at which they are ordered or allow duplicates. The interface map is also included in the table, but it's not a part of this framework. It's not a part of the collection. Instead, it's a part of the map of the interface. But it's included there for comparison. All right, let's take a look at the four interfaces really. You have a list, you have a map, you have a queue, you have a set. Out of the four, list, queue, and the set belongs to the collection type, and a map belongs to the map type. So those are two separated, but we are putting this same table. So you can compare them. Now list is ordered. Ordered means you keep the track of in the order of insertion. Map could be. Okay, map could be. Why could it be? Remember list, we have list linked hash map, right? Remember? Linked hash map, that keeps the order. Okay, remember that linked hash map? Linked hash map is this one, right? Linked hash map is that one. That one does keep the order of insertion. So linked hash map has a special field in the class that keeps track the next element. So just like linked list has who knows who next is. So it has an extra instance variable there. Okay. Now you see ordered and Q, yes, is ordered. Q obviously is ordered first in, first out, right? And then said can be ordered. So can be ordered because we can have you see that linked hash set. Okay, that is said. That's ordered. You understand it? Okay. So the next is dupes. Dupes means is duplicated allowed or not, and obviously list allow duplicate. So you have a student object, same student object. You can put in the array list as many times as you like. Okay, because array list doesn't check whether it's unique or not. So not checking. Linked list doesn't check, and queue doesn't check. You can put them. The only thing checks is the set, right? Set is no, in the very bottom you see set, duplicate, no duplicate the data can be put in, the object put in the set. What about a map? Map, it says no, but only applies to the keys. Okay, because map has key and value, right? Key is not allowed to have duplicate, but values are allowed. Okay, keys are not allowed, values are. Okay, so now what about a queue? A duplicate is allowed, yes. Duplicate is allowed for queue, right? List has something called a positional access, like an index kind of. Okay, 0, 1, 2, like a array list, you understand, right? And then even if you have a linked list, you have that also. That allows for element insertion control. So whenever you add a new element into the list, it's always added at the end of the list. When you always add at the end of the list. So if you have like A, B, C, 3 elements into the linked list or array list, the first element is always the A, second is B, third one is C. So it's always added behind it, it's appending behind it, based on the position, index, we can call just the positional index. Okay, map has to be unique key, one value mapping maximum per key. So one value, one key. Okay, Q, pose elements usually first in, first out, right? Said, uniqueness matters, so it has to be unique. So that's set. Remember we had a question on the final exam, have a bunch of values that may have duplicates. How can you remove duplicates easily? Put in the set will reject anything that's duplicate. Okay, so if we had this lecture, maybe you could have got that answer right. But we did say what set was, right? Okay, now those are the 4 interfaces. We call them list, map, and queue, and set. Now underneath that we see implementations, right? Implementations on table 2 list the company, use the collection type, implementations. Their interfaces, and whether or not they are ordered, sorted, and or contain duplicates. So we have implementation. We have an array list. You see at the very top, you have an array list. Array list implements list sub-interface, right? And the list obviously implement or extends collection, singular collection. Okay. Is it sorted? No. Can you allow duplicates? Yes. Okay. Now it has there's a little notes there. It says a fast resizable array. So that means the array is resizable. We all understand it. When we reaches the size of the array, it doubles it and creates a new array, doubles the original array in size, and copy all data from the original array to the new array. Okay, we call that amortizing, right? So that is resizable. But don't forget, array list allows you to set a constant here. So if you do know how many data items you're going to have, it is advisable to actually put that value in here. Okay, so this way, the default, the initial size is no longer the default size. The default size is 10. You know, if you don't say anything, you create a array list of the size of 10. The array size of 10. So when it reaches 11, you need to double, becomes 20. And reaches 20, you double for 40. 40 becomes 80. So it may take a few times to expansion upwardly. But if you do know, you know, at least you know you have 1,000, you can put it over there. That will set the initial array size. So you won't start with 10, instead will start with 1,000. Okay, if you know 10,000, 100,000, that's what you want to do. You don't want to start from 10 because this is too slow. Okay, so that is the node. There's a fast resizable array, but the keyword is array. So linked list, array list even sounded like something like another array, but it's an array because you think it's a list, but it's an array. The reason it's list because it keeps the order of data insertion. Okay, it keeps the order. Now linked list also implements list, the second row, you see, linked list, right? Is also ordered by index, so 0, 1, 2, 3, 4, or so on and so forth, right? Sorted, no. Dukes allowed, yes. The API linked list is based on doubly linked list. Doubly linked means every node knows the next node as well as the previous node. Okay, it's not the same as a double-ended linked list. Double-ended means you only remember the first node and last node. But doubly linked means that each node has a link to the next one, also has a link to the previous one. So that's a doubly linked list. So that is linked list. Keeps the order, but allows duplicates, but not sorted. Not sorted. Okay. Now vector is a legacy. It's a legacy. Legacy means people don't use it. Java does not support anymore. It allows you to expand as well, like array list. Okay, so it implements the list, right? And it's ordered also, so you have index 0, 1, 2, so on and so forth. Is sorted no, is duplicate allowed, yes. Now, the good thing about a vector is a synchronized, you see that word? Synchronized means is a thread safe, just like a hash table is thread safe. But for a number of reasons we're going to see in the future that we don't use this anymore. Java doesn't support anymore, it's not improving it. But if you want to use it, you can still use it, but Java is not. Try to improve it and then try to maintain it. So documents about it were from old versions of Java. So that's a vector. And so that's the third row, right? The next row is going to hash map. When you see that, you know it's based on a hash table, right? Because that's the word hash there. And there's a map word there. That word means it has a key value pair. So whenever you have the data add to the hash map, it has a key value pair. So it implements a map. That's an entirely different diagram. Remember the interface is a map, not collection anymore. Don't forget that. And does it keep the order? No, because the hash table does not keep the order, right? But the linked hash map does, right? Now we say hash map is sorted. No, it's not sorted. Duplicates are now no. That means the key again. The key does not allow duplicate values. Okay, and then no sets key value pairs. Okay, that's a hash map. Now the next one is the hash table. I brought that up earlier. That one, look at the nodes. It says legacy synchronized. Same thing as vector. So Java does not support anymore. It's not improving this anymore. Not maintaining it anymore. But nevertheless, you can still use it if you want to. And also, it's a legacy class, legacy implementation. But it's synchronized. That means it's a thread safe. you have multiple programming programs, multiple threads, try to access the same data structure to retrieve data or save data or store data, you have no problem. It knows how to take care of itself. So when a multiple program to do it. Yes?
Are we gonna learn about other stuff that like,
The what?
are we gonna learn about other things that are like standardized?
Are we what?
Like stuff that can handle multi-threading?
Are we?
Are we gonna learn about that?
Yeah. We have the second half of the course is on multi-threading. And most of these are not thread safe. Okay. And the ones are thread safe are synchronized, those two things. So we'll need to learn a whole set of things trying to manage multi-threads. Okay, that's the second portion of this course, multi-threading.
What is the cost to being thread safe? Like, why is not by default everything thread safe?
Because it's just a true, first of all, a lot of times people don't use multiple threads, so there's no need to put that overhead there. And also is quite a headache to try to make it a thread safe. You have to write a lot of code in there to make it a thread safe. You will see when we try to do our own thread safe how much work we have put in to make it a thread safe. So it's not easy. If you don't need it, then there's no point to have that. Okay, to have that overhead. Instead, there is a bunch of other implementations that are like an even linked list. For example, you have a blocked linked list. That is actually thread safe, but I didn't list over here. So there are implementations that are thread safe. Okay, and they're just harder to implement. Okay, so hash table. Hash table implements a map. So it's a map. So ordered no, and sorted no, duplicates are not no because the key are not allowed that. Okay, now linked hash map, right? That is a map, as you can see. So it implements the interface of a map. Okay, that means you must have key value pairs because it's a map. And then it's ordered by insertion and last access because insertion means the order of insertion. Okay, order also last access, which one was in access last, which location. So sorted, no, it's not sorted. Duplicates allowed, no, because the map, the key cannot be duplicates again. So key cannot be. Now nodes, linked list, hash table. So it does have a linked list in there because it has a next variable built in to keep track of the order. Okay, and then it has it's a hash table based. What we talked about in class, hash table based. Okay, tree map is also a map. It's a balanced tree. And the balance means we go with log n because it's balanced. Okay. Most time it's a red black tree, so it's a balanced. Okay. Sorted is sorted. When you access the tree, whenever you want to access the tree, you want to display. This is a hash map, right? If you want to display all the keys, right, like a tree map, right, and then you display them in the order of is ascending order. The smallest key to the largest key. That's when you use a hash map or tree map. Okay, it's always the leftmost node. I don't know if you remember when you have a tree, the leftmost node has the smallest value. Okay, the rightmost node has the largest value. So when you display a tree, you always display in the order from the smallest one to the largest one. You just do something, I don't know if you remember, that's called in order. Okay, in order traversal. So when you have a tree that's in order traversal, it goes the smallest one to the largest one. So that's what it is. So this is sorted. Duplicates are not allowed because the key is not allowed, right? Now priority queue, Q, and order by priority, obviously, is sorted, yes. Because it does the same thing, because when you move from the priority queue, is always sorted by priority level. Highest priority come on first, second highest come on next. So, and duplicate allowed, yes, it is allowed. Okay, now you understand how priority queue is implemented in Java API is based on heap implementation. Remember heap we talked about last week? Heap implementation. And because the heap implementation, do you remember the big O's for insertion and removal?
Insertion was log n, right?
Removal?
Is that n log n?
Think again. Nobody remembers? Yes.
Log n.
Both log n, right? The removal is implemented by something called a trickling down. I don't know if you remember. And insertion is done by something called a trickling up. So you put your value at the bottom, and you find the right spot by comparing to the parent. So trickling up is a little bit faster than trickling down, because when you do trickling down, you have to compare the two children and see which one is smaller. And then swap smaller one up, and then you want to insert it down. So in either case, the big O time complexity is log n. Nevertheless, trickling up is a little bit faster than trickling down. So that means removal is a little bit slower than insertion. Insertion is just trickling up. You put it at the bottom, then find the right spot by trickling up. Removal, you actually have to drop that new value down to the right location. So involving comparing the two children. So that's the heap implementation. Because of that, priority Q has a big O of log n for both insertion and removal. So because of it, the heap sort, now we're talking about heap sort now, not priority queue. Heap sort algorithm has a big O of n log n, because each value to put into the heap is log n, and you have n values to put them in, right, to build the heap. So n log n, to build the heap, n log n. Now you need to remove them, and as you remove them, they're sorted. Can you see that? Right, because you always remove the one with the highest priority, or in this case, the smallest value. So when you move them all with the smallest value first, then is sorted, and that is log n also. So total is 2 n log n. You need n log n for the min, and n log n for the min. So we just say heap sort is n log n. Got it? But you do know that you do need extra memory space, because you want to build the heap, right? You build all the nodes to build the tree, right? You know, the heap is a type of tree, not the typical binary search tree, because there's no such relationship like the left child is smaller, right child is bigger or equal, right? Either children in general, regardless left or right, are bigger than the parent or equal to the parent, or children in general, regardless left or right, are greater or equal to the parent. So there's no specific requirement that the left one has to be smaller, right one has to be equal or greater. Okay. So it is a tree, but it's not a. It is also a binary tree, but it's not a binary search tree. It's not a search tree. Okay, that's the key. So it gives you n log n for sorting or heap sort. It has a big like a space complexity as n plus the number of levels, because you need to swap. Okay, when you move Jupiter down, Jupiter up, so you need some extra room to hold the value to swap. So that's minor though. But
Wait.
you understand.
is that complexity for the heap itself or just heap sort? Because I thought the complexity was O1 for heaps, and with respect to memory like space.
Oh, one. What do you mean?
Yeah, isn't that what is the space complexity for space? Yeah, space complexity the same for heap and heap sort, or are they different?
Well, heap, heap. Well, that's not a. It's a data structure, right? Heap is data structure. Heap sort is an algorithm. Then you're gonna have time complexity and space complexity. Heap has no complexity. It's a data structure like an array. What is an array? Right. But if you want to do say sequential search, that's an algorithm. It's a way of doing things, right? That's what the procedure of or completing a task. So that's an algorithm. So when you talk about algorithm, you have complexity. So heap sort, that's an algorithm because you're sorting your values, and that's n log n. Remember that? N log n. But heap itself, there's no algorithm involved. It's just a type of data structure. So, all right. Hash set is a set, right? Implements a set. Linked hash set, implement a set. Tree set, implement a set. Those are all set. Because they're all set, there are no duplicates allowed. You see that? Okay. Linked set keeps the insertion order. You see the order? Linked hash set keeps insertion order. And the tree set is sorted. Sorted means if you traverse it, it goes in order traversal. It goes from the smallest one to the largest one. So when you display them, we display them sorted. Tree set, hash set no, and duplicate is not allowed because the all says sorted not, sorted tree set is. Okay, so that's the implementation. That's the common implementation. There are a lot of tens of other implementations that are not used that often, so I didn't list them there. Okay, now let's take a look at the methods. Okay, what I had on table in table 2, those are the concrete implementation. Those are concrete APIs, right? Now let's take a look at the methods they have. Okay. Now the collection is an interface, and it has sub interfaces, right? List, queue, and a set. Provides several valuable method signatures as shown in table 3. So that's the next page altogether. Okay, so now variables, sub-interfaces, and methods. Now, you look at table 3 at the top, right? If you look at the column 2, 3, and 4, columns 2, 3, and 4, you see there's a list, set, and map. Okay, list, set, and a map. So these are the parameters provided by list and set and map interfaces. Okay, so there are a lot of uniform things there. Okay, when you have an add method, okay, look at the first row and the math, right? The method. You have an add method. Is it the add method? Okay, who has add method? List has add method, right? When you have array list, linked list, you have an add method. Okay. And add method also is used in set. Okay. In set. But you don't use it for a map, right? So what's the method for map? You remember? When you have a map, you can put, exactly. So if you go down the third from the bottom, you see the put. And the put, you see this is not applicable for list, not applicable for set, but under map parameters, you see that is a key value. So for map, you use a put, and you don't use add, but you use add for list and the set. Okay. Now, when you use for list, you can use index as a optional. Okay, you can specify where you want to put it. Okay, where you want to add it, where you want to add it. So you see the square brackets there. You see the square bracket. Anything square bracket means it's optional. Okay, you can use the index or not use index. If you don't use the index, we'll put in the very end of the list, okay, which I mentioned before. But if you do use the, if you use a, if you do use an index, that means you're gonna insert your value at a location you indicated. So you say add parentheses 3, comma, followed by say the object, right? It means you are inserting the object at the index 3. And it's inserting there. You're not replacing the data over there, you just add it over there and inserting it. That means it involves another thing to do, that's push all the elements that are already in there up. You need to shift up to create a space to allow you to insert. You understand? So because of that, the big O is already N. Can you see that? You understand? When you do add, you need to insert, you need to push the existing values from that point on up to create a room for you to add a new value in there. So because of that is N already. But if you don't indicate the index, you just say add student 1, for example, then the big O is 1, because all you are doing is add the student object at the end of the list, at the very end, so big O is 1. You know the index value. Okay. All right, then when you do set, you add the element to the set, and then you return a Boolean. Boolean means it was added successfully, you get true, otherwise you get a false. This is especially useful when you try to add something into a set. If it turns false, that means that value has duplicates. It won't allow you to add. Okay, and is not applicable for map. Okay, contains is for list and set, see, but not for map either. And it contains key that applies to the map only, but not apply to list and the set. Because we're talking about a key, only map has key, right? So all those return Boolean. Contains value also applies to map, but not applies to list and the set. Get applies to list, applies to map. Okay, so you can use index to get the value at a particular location, or you can use get key to return the value. Okay, so if the argument or parameter is the key, you return the value. Now, what return is the object? Is the object. Okay, so when you have a list, whether linked list or array list, when you specify the location, you return the object. Okay, return the object. Whatever you found there. In other words, index of applies to list only, the linked list, array list that works for iterator, works for list, as work for set. List and set. It says none. None means no parameters needed, no arguments needed. In the parentheses empty. It's not. All right. So key set, obviously, you need to see the key is the one for map, right? So parameters no need, just empty parentheses. And it returns a set, so it returns all the keys in one set, and that's unique. So that's why it's a set. The keys must be unique. Put, that only applies to map, so key value returns a void. Remove applies to all three. It applies index, it applies to list, set, and map, right? And returns void, it just remove. Oh, I'm not sure. Remove, I don't think it's an object, I think. It's not or the value, not the void. I don't think it's a void. Maybe I typed the wrong there. And the size applies to all the list, the set, and the map. Returns integer. The size of the list, like the map, like size of the set. Okay, so that has all the methods. Now those methods you can see they all inherited from the interfaces, list, the set, and the map. Right? So this way we standardize. So if you know how to use array list, then you really know a lot about linked list because they all implement the same list interface. They share a lot of methods, names, parameters, but they don't share the same implementation because one is array based, one is linked list based. Okay, so that's the benefit. Now let's move to an entirely different thing. Let's go to collections class. Okay, this time it's class now, not that interface. Notice I put a plural there. Collections, class, even I specified the class, algorithms. So these are the algorithms we can use, right? All right. Now, collections, I think we used it before when we do sorting, right? Collections start sort. Okay, now let's take a look. And sort either somewhere towards the bottom of the table, table 4, the third row from the bottom, you see sort, right? You see sort. Now, so what is needed? You see, what is needed? You need to sort the list. So what that tells you is sort method can only sort the list, cannot sort like a set, cannot sort a map, cannot sort a queue. Okay, you can only sort the list. So who's the list? Whoever implements the list interface belongs to the list. Who are they? Stack, also the array list, linked list, right? So remember that first page we had a stack, array list, linked list. They all implement the list, so they belong to the list. So that means you can use collections.sort to sort any sort data collection belongs to those three, right? So, but can you sort something like a map? No. Can you sort something like a queue? No. Okay, it has to be a list. So now, also take a look at sort again. The way to use it is as a parameter, you say the data type, and then you put the object in, right? Like the list, the object name of the list. And then you see the square bracket, it says comparator. That means comparator is optional, right? That's optional. You can have a comparator, you don't need a comparator, but usually you must have, you must have a comparable. That you have to have, right? You know the difference between comparable and comparator, right? Comparator allows you to override comparable. Okay, if your comparable is not what you want, say I think I made an example, I don't know if you remember. If you're comparable, you want to compare students by name, but you change your mind, you say, now I want to sort them by their GPA. Now you implement a comparator to override sorting by name without actually going back to the student class, rewrite that comparable, the comparison method. Okay, so that's why it's in square bracket, it means optional. If you want to do it, you can do it, but you don't have to. If you don't put it in there, you will use a comparable. Okay, so that's, and what it returns is a void, so it doesn't return anything. It just sort the original list. The original, whatever the list is now, it's sorted. It doesn't create a new list, in other words. It doesn't create. It just sort everything inside the original list. Okay, so so that's a good example, right? That's a good example. Now, there is a corresponding class in applied to arrays. I hope you remember the class name called arrays. Okay, so those two are like sister classes. Okay, so you have arrays. It's also plural, sort. Okay, now over here you have an array. Right? Now optionally you have a comparator object. Comparator and comparator. So that part is optional, okay? That's optional. I put a square bracket in there. So if you want to override it, you're gonna have a comparator object. If you don't want to override it, then you just use array. And then you'll be just sorted by array. Okay, so you'll be sorted by the comparable and your student. And then you'll implement comparable. You have to use a compare to method in there. Okay, so array star sort as well as the collections dot sort. So those are list. You see, you have a list type. Okay, you take a list, and then you have comparator and a comparator. So you have these objects. Okay, so you can sort a list. You use collections sort, and if it's array star sort, you sort array. Okay, so these are two similar. They're similar. Both can take a comparator object if you want to override a comparable if you want to. Okay. But again, arrays is not considered part of the collections part. All right. Now let's take a look at the collections class algorithms. You see. Okay. And if you look at the algorithms, you will see, let me see, not to be confused with the interface collection, contains several variable static methods. These methods can be invoked on a variety of collection types. So we commonly use the types and return values. So these are the static methods, so you can just use them together with the name of the class name collections. Okay, so you have add-all. Look at the add-all. Look at the add-all. Add-all has something, it's a method, right? The first method there, add-all. And see the parameter. What kind of a parameter can you accept? You can accept collection. So who is the collection? Set is collection, Q is collection, list is collection. You see? So any kind of data structure that holds collection belongs to whoever implements the collection interface, the first diagram on the top, that one, that belongs to the collection. So that, you see this a lot in Java doc. Now, hopefully it will tell you, what is allowed, what is not allowed, right? And it returns a Boolean. Max gets a maximum value. Again, you see, you get a collection, right? So include the list, include but what about arrays? Arrays not included because they don't implement it in the collection interface. Okay, so you have the corresponding one for array, called array start max. So arrays, collections are very similar. Min, same thing. Disjoin. Disjoin means that you're going to, you see, you have two collections. Okay, just to see if they. You have two collections. So the parameter takes two collections, collection 1, collection 2, right? And it returns a Boolean, right? The method disjoin. What it does is check if the two collections has overlapping elements. If they're both unique to each other, then you say true, return true. That means there's no overlap. But if there's an overlapping element in both collection, then it return false. That means there are duplicates inside. Okay, so that's disjoin means. Frequency, how many of those objects, right, in that collection? You see the parameter is the collection object. So how many particular objects inside that? Okay, that's a frequency. So that's. Remember our dictionary? We had like a hash set, right? Dictionary, set, hash set, and a hash set is part of the collection. It's not a map. Map is different. Map is not a collection type, but a hash set is. Because a hash set is, so you can take the hash set, you can test an object, see how many times that comes in the collection. So that's a frequency returns integer as last in first out the Q. Last in, first out of queue, that's called a deck. There's another, it's pronounced as deck. Okay, it's a special type of queue. Usually queue is the first in, first out, right? There's a last in, first out. So, so it's a special type of queue we call deck. Reverse list, it applies to list. Shuffle list, so if list, you can shuffle the list. You know shuffle means to shuffle them, mess them around, okay? Break the orders and stuff. And copy list only from destination to source. Applies to list only. All this applies to list only. Rotate applies to list only at an integer distance. When you know rotate, you know rotate. Do you know what that means? You don't know what rotate means? So if you have a linked list or array list is array, right? So this is an array, and you have, say, this is your value, say 5, 2, 0, 3, 9, 7, right? If you want to rotate the same array, 1, 2, 3, 4, 5, depending on the distance, if the distance is 1, that means you will push 2 to here, 5 to here, 2 here, 0, 3, 9, 7. The distance is 1. It's rotated. Okay, and you can rotate it 2, and this is used in encryption. There's something like that. So that's rotate. Then you have to specify the distance, and then you have rotate and swap. You have a list, swap initial position, one position to another position, and swap. So you have array list, any kind of list will work. Binary search, this is not on array, so that's a binary search for list. You do an object of a list. So what it's going to do is you're going to sort it, I guess. Then you do a binary search of the list. So and the fill, you fills the list with object fill. It applies to list only. Sort is applied to list also. And then replace all. You place a list with the older values with new values. And new set from map. So you create a new set from an existing map. That means you take the keys, create a new set of a map. All right. So so these are called algorithms, because if you look at those methods, they always do something, right? The shuffle, the list, the fill, the search, swap, rotate, copy. So those are algorithms. Then the final page, I think, right? So we have all the big O's. Okay, algorithms and data structures are optimized for different reasons. Some for random element access or insertion, deletion. Others for keeping things in order. Depending on your needs, you may have to switch algorithms and the structures. Common collection algorithms, the types and the average time efficiency are shown in table 5. So algorithm add remove from end is big O for 1. That applies to Java collection framework, collection class algorithm, collections class. So when you use those data type, then collections class, right? And algorithm array list. So that's 1, add remove. And get, set, add, remove from index array list is n. Remember when you get something or add something at the index, you have to shift up. That's why it's n, right? Because you really just inserting, right? At the index. And also when you have an array list, and then you have contains index of, that's n. Whether it contains an object or not, you have to go through the array list, see if it contains that. It's a search, so it's n. Get, put, remove contains key, that has to do with the hash map. Hash map is 1, you see that? Hash map is a get, put, remove, contains key. And the hash set is add, remove, contains, that's 1, because it's a hash. Linked hash set, that's a linked list involved, that's also 1, add, remove, contains. Linked list, then there's 3 linked lists in a row, get, set, add, that's all 1. 1 and n get set from an index. From either end is 1. From the middle is n. Contains index of the linked list is n because you search. Peak priority queue is 1 peak. Okay, add remove priority queue is log n because it's a heap base. Remember heap base? Okay, so if you do add remove into a priority queue because a heap base is log n. Remember that? Okay. In the beginning of 218, we implement our priority queue using an array, but that insertion or add is n because it's an array base. We have to sort it. But now we talk about a new implementation using heap, and that's log n. And remove get put contains key. We have a tree map is log n. Add remove contains a tree set is also n. Okay, when you look for tree set, you use the unique thing is the value, right? The whole data item. But tree map is searching by key. So when you do contains key is log n. But contains value is going to be n. It's not log n anymore. Okay? When you do a tree map, even though it's tree based, but tree is not organized by value, it's organized by key. So if you're looking for key, it's fast. Looking for value is not organized at all. So you have to go through every single item to find it. So that's n. Okay? So contains key is log n, but contains value. Okay, finally I have this. That's the first day, first hour, last semester in 218, we talked about big O. We finally coming back to the same thing. We said, what is big O, right? Big O of 1 is a notation. Time is a constant, regardless of the number of elements. See, number of elements, that's important. Big O of n, time is linear to the number of elements, linear. Log n times the logarithmic to the number of elements. And log n times linear rhythmic to the number of elements. And then this is another one I forgot to put in. That's n squared. That's quadratic. Okay, that's quadratic. I think that's it. That should put a somewhat a closure to 218. You know, all the things we learned in 218 are here. Then there is a couple of things I want to talk about in this semester regarding data structures. There is something called a string, so I want to talk about that. You know, it is which uses a lot of number expression to process your data structure, data structure. So very convenient, easy to read, very concise. So I would like to spend an hour and a half on that. And then I would like to talk about graphs. Okay, graphs is optional data structure. Usually it's not. It's optional for 218. If we have time, we do it graph. If we don't have time, we don't do graph. But it's a very important data structure. Neural networks and all the maps. Like Google Maps and all the maps. Today, like ChatGPT, all those are real, just graphs. Okay, things are related in all kinds of crazy ways. So may have to spend like one lecture or two on graphs. Very interesting, very unique data structure. And once we finish that, we just need to have an exam that will kind of give you another chance to prove to me that I didn't make a mistake to keep you in this class. Okay, so we can do that in 2 weeks, which means end of the 5th week for the semester, or 3rd into the semester, or 6 weeks. And then 3 weeks, either 2 weeks or 3 weeks. Don't forget, next Monday we don't have a class. Next Monday is President's Day, okay? So we don't have a class. So maybe you first exam. And that will count like a third or 30% of your final grade. Okay, we still have a few minutes. I'm not gonna touch any new things. Do you have any questions? Yes.
When it comes to like overall grading, I know you mentioned the first test is going to be 30%. Do you know what like the rest of it's going to be, or is that
It's
still?
all 30% each, so we have two more after the first one. So we may have a project or a exam or just two exams. So the project, I think it doesn't work out. I mean, it's good for you, but it's just taking too much time and then you're not focusing on data structures instead of building like a computer, you're building graph, it's like a GUI interface. You're having a lot of fun, but you're not learning what you're supposed to learn. So I'm a little bit worried about that, spending too much time on project. What is good though, there's a guy in here, I think there's two years ago, he graduated from here and went to Stony Brook and he got a job for this summer, like an internship job in the summer from Amazon. So he was so happy telling me they paid like 10 grand. So what was 1 month on 10 grand, 1 month, so 3 months of 30 grand. So that was pretty good. In today's environment, right? So I think it's not that bad. You can still have good opportunities. And the data structure is so important in those job interviews. That's what he's saying also. So I think maybe we should focus more on data structure than spending time building something. Maybe you have fun, but you didn't really learn that much, right? But you spend a lot of time just because you like it. Okay. So maybe have 2 exams after this first one. And but one more thing though, I think I mentioned, we're not gonna have like an open book and open internet. So just come in, you get a piece of paper, a pen, and you just write out. This is the same way students will test you. Because if I ask you everything I know about, you can look it up on ChatGPT. So it doesn't really reflect how much you learn, how much you know, right? Because if you're not ready, you want to know now. Right? You don't want to know during the job interview at that time. Make sense? It's not like I don't like you. It's just like it's not going to help you by allowing you to go online, copy and paste. So you're gonna write down the answers, your notes, nothing. But questions are be more less coding, more like explanation, understanding of the algorithms, like I talked about. Like for example, we talked about heap, right? Heap sort, for example. How you do insertion, how you move, and talked about hash table, talked about double hashing, for example. Talked about quadratic coding, all those. Talked about we talked about the vertebrate trees. Did we? I think we did, right? Vertebrate trees, how to build out of the trees and keep it balanced. Is there anything you think we didn't cover this time and you guys had trouble with from last semester? I didn't pay too much attention to linked list this time, I think. I didn't mention, it's doubly linked, but I didn't mention how exactly deletion is happening, how to do deletion and insertion. I didn't, draw the diagram and show you how to do it. So if you have trouble, you should let me know. I'm in no hurry, if we have to spend the whole semester on data structures, I because that will prepare you for the job interview. Rather than show them your project, which is useful if you do have a good project, but you understand you are competing. The only thing that is competing with other students, other applicants, based on the same standards is the data structure questions. Because your project will be entirely different from other people's project. So it's very hard to compare you with someone else. But question like a heap sort, for example, that's the same across the board. You don't even need to talk about language. It doesn't matter what language you use, right? So that's how they ask you. Because they cannot expect you just know Java, you don't know C or C++. They don't care. Same question across the board for everyone. So heap sort, or they want to ask you things like a binary search and linked list. So you need to know, right? Like radix sort, the big O's, you need to know. Like hash map, stuff like that. So coding will be less important, more like an algorithm understanding. Like a merge sort, for example, you can implement it within any language. So I won't even ask you to implement it because you can always find out online if you need it. So there's no point to make you implement it. You're on the spot, right? It's like times table. I think people just give you a calculator. You don't even require to know times table nowadays. The world's changing. Last week we talked about, we have a big scholarship for the Fry scholarship. You know that $5,000, right? It's a math scholarship, mathematics. So the requirement was you have to finish the Calc 2 and then finish the 1 or 2 other more advanced math classes, right? So it's a math scholarship. It's $5,000. That's like donated by one of our alumni from our department, math department. Now the school came in last week saying that's wrong to require math courses because you're discriminating against people who are not good at math, and they are victims. So the new rule is you don't need any math, not a single math, not even algebra or any times table, nothing, no math needed now. So now the question becomes how I'm going to decide, right? Who's going to get it? And then it's based on your essay. And then you're going to have to tell people whether you are one of those victims, discriminated against, the victims. So the worse a victim you are, the higher chance you get. So no, that's a big thing. So starting this method, if you want to apply, play victim. Women, for example, that's a good one. Person of color, but not Asian. Asian is the worst. Asians, no chance at all. All the Asian applications get thrown out. That's the first thing they do. So that's the next world.